Okay, today our chapter is function. I am going to explain function. What is function? What is its inverse? And how to write it in mathematical form. Now, about function. Now, first of all, we have to understand function is a special type of relation. Now, in my previous chapter, I have already explained about relation and Cartesian product. Again, I will explain. Relation is subset of Cartesian product, and function is a special type of relation. Now, what is the difference between function and relation? First of all, you have to understand. Now, I will say one sentence. All the functions we can say relation, but all the relation will not be a function. Okay, now definition of function. Let A and B be two non-empty sets, and B be two non-empty sets, then our relation R, I have written here R, our relation R defined from set A to B, is known as a function. Now, if in which condition it will be function? If each element of domain, that is domain means set A in this condition. Domain means set A associates with a unique elements of set B. Now set B here is codomain. It means all the elements of set A domain and all S should associate each element unique element of set B. Now I'll give one example here. Suppose this X. This X represents all the elements of set A, and this Y represents all the elements of set B. This one is domain, this one is codomain. Now, suppose in domain, I'll take few examples, few elements. Suppose 1, 2, 3. Okay, 1, 2, 3. These three elements I have taken here in domain. This X means 1 also, 2 also, 3 also. And in set B, I'll take ABC, three elements, ABC I have taken. Now, this ABC, Y represent A also, B also, C also. Now, this domain, if this 1 has image A, 2 has image B, 3 has image C. It means this A is image of 1, B is image of 2, C is image of 3. Then this one will be a function. Now this X, I have written here X. Actually, you have to understand X means this all, Y means this all. It comes in function later in mathematical form. Now this is also relation, but what type of relation this? In this relation, this each element means 1 has one image, 2 also has only 1, 3 also has only one image. That's why this relation R will say function. Now I'll replace this R by F. Now this function, this is example of function. Now domain, codomain. Now I'll explain in which condition relation will not be a function. Now I'll give here some example. Suppose this one is set A, this one is set B. Domain, image, domain, codomain. Inside codomain, we have to find image or range. Now, suppose there is a relation, I'll write here R. Now, in which condition this R will be function? R, already I explained the main condition. Now, few more examples. Suppose 1, 2, 3. Now, this 1 has image, for example, 3. This 2 has image 4. This 3 image 5. Okay. Image of 1, 3. Image of 2, 4. Image of 3, 5. Now this is also function. but in which this relation, now this relation we can say function. Right now it is function because this 1 also has image, 2 also has image, 3 also has image. That's why it is function. Now if suppose these 3 doesn't have image, now 1 has image 3, 2 has image 4, but this 3 doesn't have image. That's why this is not a function. It will be a relation. It is only a relation, 1 to 1 into relation, not onto, because this 5 has no pre-image. Now in this condition, this will be relation, it will not be a function. Now another condition, if we remove these 3, now that relation will be a function. Now that will be a function because this 1 also has image, 2 also has image. Now this is function. Remember that this 5 doesn't have pre-image. No problem. This function. Now in this condition, this R will be a function. Okay, I'll write here F. Now one condition. Now types of function. Next step, types of function. I'll write here types of function. One to one, onto and into function. Onto and into function. Number 2, many to one, also 2 types, onto and into function. Now function are of only 2 types, 1 to 1, onto into, many to one, onto into. Remember here, in case of relation, 1 to many, that will be only a relation, that will not be a function. Now these 2 are also in relation. These 2 types of relation will be function also, but third one, 1 to many, will not be function, that will be only a relation. Now I'll explain these 2. In which condition it will be 1 to 1, onto into, many to one, onto into. Now onto and into, I have already explained in previous chapter. Onto, again I will say, onto means if image and codomains are equal. If image, set of image equal to set of codomain, at that condition function will be onto. If set of image is proper subset of its codomain, at that condition function will be into. Here also same, onto and into. Now I'll explain the example of 1 to 1. 1 to 1. First one, you have to remember, first one is domain, second one is image. Now what is the meaning of 1 to 1? 1 to 1 means one domain, one image. Many to 1 means many domain, but image is 1. That is common. Now here, again I will take the same example here. We can take this one example. Now I have written here set A and set B. First I will drop this one. Set A and set B I have taken. Now in this set A and set B, set A has 3 elements, 1, 2 and 3, and set B has also 3 elements, A, B, C. Now I will drop this one also because already this one is function. Now this one has one image of 1 A, image of 2 B, image of 3 C. It means one domain is, there is one image. One, we can write like this also, 1A, 2B, 3C. Now, domain image, domain image, domain image. Now, in this case, this is types of one-to-one function. One to one, one to one. Now, in this case, it is onto function. Why it is onto? I write here image. Image set. I write I. Image set means ABC. A also image, B also image, C also image. Now codomain, set of codomain. Set of codomain here I write C. That is also ABC. And domain, domain of the function. Okay, I write D. 1, 2, 3. Now in this case, code set of image A, B, C. Set of image is equal to set of its codomain. That is I is equal to its codomain. That's why it is onto. One to one onto function. Now this is the condition. I have given an equal sign. This we can say in another word also, if set of image is improper subset of its codomain. Improper means equal. Now set of image and is equal to set of its codomain. That's why it is onto function. Now I'll say now another example, one-to-one into function. Suppose I write here one more element, that is D. I added one element here D. In set B, there are 4 elements A, B, C, D. That's why it's codomain. Set of codomains A, B, C, D. Set of codomain A, B, C, D. Now it has 4 elements, but out of these 4 elements, A has pre-image 1. Remember that. A is image of 1 and 1 is pre-image of A. B is image of 2. 2 is pre-image of B. C is image of 3 and 3 is pre-image of C. But this D doesn't have pre-image. That's why yeah, this set of this D, we cannot write elements of set, image set. In image set, this D doesn't come here. Only A, B, C are elements of set, image set. Now, in this D comes in set of codomain. That's why in this case, set of image is subset of its codomain C. Set of image is subset of its codomain. Subset also proper subset. Proper means not equal. If equal, that is improper, but here image set is not equal to its codomain. That's why it is improper subset. Now in this condition, this function will be one-to-one into function. Again, one domain, one as unique image. 1 A, 2 B. Now these are order pairs. I have written in terms of order pairs. And 1, 1 into function. This is the example of 1, 1 into function. Now again, now I'll go to next, many to one, onto and into. First, I'll rub this one. Now, many to one, onto into. Now, suppose there is set A and there is set B. Okay, I write here function f. Fx also I write. This x means domain. Okay, here 1, 2, 3. Suppose 1, 2, 3 are elements of set A, which is known as domain, and we have defined the function from set A to set B. Set B is codomain. Okay, suppose here same, I'll write here 3, 4, 5. Okay, 3 elements are there. Now many to one, many elements of many domain has same common image. For example, suppose if this one has image 3, this 2 also has image 3. Now many means 2 or more than 2 has same image, and this 3 has image 4. Okay, I'll drop this 5. Now in this case, many to 1, many to 1, this is also a function, this is also a function. In this function, this 1 and 2 have their common image, that is 3, and this 3 has image 4. Now in this case, domain, now image, set of image, we write 3 and 4, and set of codomains are also 3 and 4, and domain, set of domain 1, 2, 3. Now in this case, image set of image equal to its codomain, equal to its codomain. That's why it is many to 1, many to 1 onto function. Now why it is onto? Because this 3 and 4 set of codomain, and 3 and 4 again they are image also. Now this 3 and 4 set of image also. Now this image set and codomain set are equal, that's why it is onto. And why many to 1? Many domain has one image, common image. That's why it is many to 1. It is also function. Now this is example of onto function. Now into function. Suppose there is 5. Suppose in set B, I have added one more element 5. Right now in this condition, this is also a function. This is also a function, but this is not onto. This is into function. Why it is into? Now, right now, this 5 doesn't have its pre-image. This set B. In this set B, elements of codomain. This 5, 3 is image of 1, 3 is image of 2, 4 is image of 3, but this 5 doesn't have its pre-image. That's why this comes in set of codomain. Now 3, 4, 5, 3, 4, 5, these 3 elements are set of codomains. Now inside these 3, 4, 5, these 3 and 4 are only image. That's why image, set of image elements are 3 and 4. Right now this image set is proper subset of its codomain, that is 3 and 4. This is subset of its codomain, that is C. I subset of C, proper subset, not improper, proper subset. That's why it is into function. Now these are the types of function, onto, into. Now another very important, here is I have written fx. Only name of function I have written here. Now you have to understand here is, now I'll write how to write function in mathematical form. That is very important. Now I'll give one example. Mathematically, function, we have to write function mathematically including variable domain, that is x. Okay, it means suppose there is a set A, there is a set B. Okay, this set A, x, all the elements of set A represented by this x, and all the elements of domain represents by y. Now suppose let f be a function defined from set A to B. Now this one we have to read f be a function defined from set A to B. It means from set A to B, that function has defined. Now this f is only name of the function. Now mathematically function is formula, just like its formula. Now I'll make it clear from here. Suppose I write here 2x plus 1. I wrote there 2x plus 1. Now this is formula. This formula is function. Now it has another name. You have to understand this 2x plus 1, especially this is function. Now in this 2x plus 1, this is formula. Now let's say formula. In this 2x plus 1, there is use of variable x. That x represents elements of domain. Very important point. This x represents elements of domain. Okay, in this function 2x plus 1, now it is function. Then we have to give its name. Okay, I'll give the name of this function f. Now name of this function is f, just like is any object. Now in this function there is variable x. Now that's why you can say this is function, its name is f. Now again we can say it in another way. This 2x plus 1 is function of x. Function of x. Now 2x plus 1 is function. Mathematically we have to understand this. And this, in this function there is use of variable x. That variable x represent elements of domain. Now in this function, okay, fx equals to 2x plus 1. Now this 2x plus 1 is a function of x. Now in set A domain, okay, I'll take few example, few elements I'll take. Okay, 1, 2, 3. Let's say 1, 2, 3. I have taken 3 elements which are elements of domain. Now this x represent 1 also, 2 also, 3 also. Now value of x in this formula. Now value of x, write 1 here, 2 here, 3. Now after writing the value of x 1, 2, 3, this formula gives, or this function gives another value. It means, for example, when x equals to 1, then f1. Right here value of x 2 times 1 plus 1. Now we will get 3. Now this 3 is the value given by this function, and value given by this function is known as image. Now image has definition of image. We can say value given by a function. Very important point, is known as image. Image, generally we denote image by y. Now image, that's why fx equals to y. We write in this form also. This x, now here is only name of the function I have written. This inside bracket there is x. What you have to understand, there is a function. There is a function means like this: 2x plus 1, 3x plus 1, 4x plus 1. Any formula will be there. I haven't written there. In that formula, in that function, write the value of x. X means domain. Then that function gives another value. That value is called image. Now y. Now here is this. That's why we can write here also. If we write here y, then meaning of this y is, write the value of x here. It gives another value. That value represents image. That is, I have written here y. Now here also y. See, this x and this x, these are elements of domain. Now this y we can say image. Okay, this 3. Now I write here 3. Now 1 gives image 3. How this 3 comes? According to this function. This function, when we write value of x here in this function 2x plus 1, it gives value 3. That 3 is called image. Now, and this, when x equals to 1, it gives image 3. Now we can write like this also in terms of order pair 1, 3. Now this 1, 3 means there is a function. In that function, value of domain 1, when you write value of domain 1, it gives image 3. Now this is an order pair. Now another thing you have to understand, domain represents x coordinate, image represents y coordinate also. Now x coordinate, y coordinate. Similarly, I'll take another value of x, 2, which is here 2 times 2 plus 1. This gives image 5. Now its order pair 2, 5, and f3, 2 times 3 plus 1 equals to 7, 3, 7. Now, by the help of this function, we found image 2 has image 5 and 3 has image 7. Now, in diagram we can show function like this also, and same thing we can write in order pair like this also. And another very important, this x coordinate, domain, x coordinate, image, y coordinate. Now we found here only three points. Now we can say these are the points also, 1, 3, 2, 5, 3, 7. Domain, image, domain, image, domain, image. Now if we plot these 3 points, we can find more points also, because this function, this x, set A to B, we can find so many points here, and these points we can plot in graph also. When we plot in graph, either, right now this is linear function, that's why it gives a straight line, but if there is quadratic, cubic, then according to that curve we will get. Now in case of linear, straight line, this is the equation of straight line. This equation, another way, this equation we are saying function. Now don't be confused, function, equation also a function. Now from this function we found points, plot it in graph also we can study the characteristic, nature of the function. Okay, one example I have given. Now this, in this case, this is function of 1 to 1 into function. Each domain has unique image, and image set and codomain are equal. Now this is the example of function. Now just like this, you can find image of any function. Now, and you can show in diagram also. You can write like this also and study, and from your textbook see the question, find domain and image, and study the types of function. Okay, today this was. Next class I'll explain about inverse function. Okay, thank you.